Hello friend, welcome. We always want to try to use what we learned to solve some problem. In this video, let's try to use Haskell to calculate the pi, okay? So let's get started. GHCi and clean up. So we know there's a formula to calculate the pi. It's like that. This is the comment, okay? It's like pi equals what? Equals 4 is 4 over 1 minus 4 over 3 plus 4 over 5 and minus 4 over 7 plus, you get it, right? The pattern. Next one will be 9 minus 4, 1, 3, 5. Okay, this one is 11 plus dot, 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 right? Let's give it a try to get some feel about it. Okay, so enter. This is comment, so nothing is displayed here. This is come. Now let's try to calculate that. Control A to go to the top. So let's calculate that, and Control E, remove that to see if it's close to 3.14 something, right? Oh, kind of close, right? Not very. Now, so we want to calculate that using Haskell. So it means, okay, to do that we need to learn something. For example, we want to sum up a list, right? For example, we know this is a simple list, right? So we can sum up using the built-in function sum. Okay, let's define. Okay, so sum, yeah, we can use that. Go to the top, sum, yeah, 10, right? If we can build a list like that, then we can sum up to get that. Okay, now so we can take the 4 out, right? So for example, if we can do something like, if we can get something like this, right? 1 over 1 and negative 1 over 3 and positive 1 over 5. Yeah, if we can get that out, and then we are almost done, right? So 1 over 9, negative 1 over 7, 11, and blah blah blah, like that. If we can get that out, oh, it is displayed as the decimal numbers. Yeah, that's fine. But how can we get that out? First of all, can we get these things out? Like 1, negative 1, 1, negative 1, dot dot dot, right? Can we get this out? Right? There is a system provided function called cycle. Let's play with that. Cycle, for example, cycle 1. So yeah, cycle 1, if I press enter, it will go forever, because this one is like infinite cycling it, right? So, but we can use a take thing, right? Take the first 3 of that, right? So if we take 30 of them, it's like that. So cycle will repeat the element inside the list to like unlimited, but take will take the first 30 out of them. So now what if we cycle this list, right? Oh, takes 3 is too is too few. Okay, so what about take 8 of them? You see? So if we do that, we can get this out. Why do we need that? You will see shortly. Okay. What's next? Okay, we still need something like zip. Zip. Okay, before zip, we need to learn the tuple. What is tuple? This is a tuple. This is a tuple. So how can we use a tuple? Let's see if we do that equals 3 and 7. Can we do that? Yes. So now x is 3, y is 7. That's tuple. What is zip? Zip will like combine 2 lists. Okay, so let's try it. Zip like 1, 2, 3 and 7, 8, 9. Okay, you see the output is a list of tuples. 1 is bundled with, right? Is married with 7, and 2 is married with 8, like that. Okay, so what is infinite? You know this one, right? But what is this guy? If I press enter, then it will run forever. It will go to the infinity. So let's take out 5 of them. Yeah. Do you get it? 9. So we'll take the first 9 of this unlimited list. Okay, infinite. Okay, what can we use that in our zip? So this guy, one of them can be unlimited because it will generate a list, right, with the length of the shortest one, like that. Let's give it a try. So instead of that, let's make this one unlimited. Okay, like that. We get the same result. Okay, now I think we are almost ready, but not yet. The next one is comprehension, right? We already know that. So what is comprehension? Comprehension is like that, right? X, for example, here is a function, right? For example, triple of x such that x is drawn from a list, right? For example, 1, 2, 5, like that. So it will generate a list. The x, right, comes from this list, and the output is based on this formula. Now let's go. Okay, so what if we want to sum up all of them, we can simply, right, do this, right? Sum of them, you see? That's the sum of this one. Now we have all the tools we need to calculate our original pi. Here, no, this guy. We want to generate this one. So before that, let's okay. So let's put this guy here. Let's try to generate our list like 1 3 5. Okay, so let's try to generate something like that, right? And 3 5 and 7 9. Okay, let's try to generate this one using list comprehension. So x is drawn from say 0 to 5. Okay, something like that. So get that, right? And now we need the odd numbers. So we can do let's use, okay, so x 2 times x plus 1, right? Those are all the odd numbers. Now we need the reciprocal, right? Reciprocal of that. So we can modify this to 1 over that, right? This is the reciprocal. Yeah, it doesn't look very good, but we know it, right? 1 and 1/3. You see, 1/3, then 1/5. Yeah, that's exactly, yeah, this part, right? 1/3 and 1/5. Now how can we change its, yeah, like its sign, right? We need positive, negative, positive, negative, right? And alternate it. And let's use this one because it's easier. We don't like to look that. We'll use that in the later step. So how can we make something like, right? Let's make a copy of that. Well, if we can do this, right, then it's better. How can we do that? Okay, so we need another generator. This is called generator. You can generate x, and we can generate another thing like y is drawn from. Now we need something like that, right? 1 -1, remember? 1 and -1. What is that? That is our cycle. This guy, right? It will go forever, but it doesn't matter because we have this guy. No, we cannot do that. We need to use something like that, x and y. X and y, the tuple is drawn from zip, this guy. Wow, it's getting more interesting now. So this tuple, right? Remember, this is a tuple, right? This guy will go forever. cycle that, but because this one is limited, right? The length is 6, so we'll get 6 tuples. Now, how can we use the y? We can use the y times this guy, right? Let's see. Ta-da! So cool, right? We are very close. Now, let's make the reciprocal of that. So we only need to change this to divide, right? Now we get 1 and 1, negative 1/3, positive 1/5, and negative 1/7, and positive 1/9. Yeah, that's it. Okay, so the final answer is the final answer is 4 times sum of that, right? Very close, but not yet, because this number is too small. That's 250. Wow. Oh, now it's closer. What about 500? Yes, it's getting closer and closer. 5,000. You see? You can play with that. Okay. Cool. So that's it for this video. Thank you for watching. See you next time. And by the way, we are doing this calculation. Let's put it back here, right? Dot, dot, dot. You see, 4 times the sum of those ordinate reciprocals. Okay.